agents are learning the word information, they will still somehow be accessible. Their internals will be accessible. If not, we'll be in trouble. Of course, if you don't care, if you are really hoping for these agents to take over so that, we will be, what's that, Matrix or one of these movies where we'll all be in some other planet on life support systems and these agents will be running the Earth and the rest of the universe, then you're fine. Okay, but if you want to be part of, figuring out what these agents are doing, then this is going to be good. Yes?
My question is actually along the lines of why do you care in many cases? Because, like, for instance, I go to a restaurant and I order some food, right? I know exactly what they're doing in the kitchen to be not out here, but it tastes good to me. So for a lot of things, if I build models to say, like the Facebook chatbot, not chatbots, but the bots that were doing negotiations, ultimately, if I come out on top and I get a better deal because of it, why do I care?
Again, that's a very interesting question. Again, we are getting to having the discussions that are happening at the frontiers of the field right now. So every time I wind up being in some meeting with Jan Litwin, his argument is nobody needs explanations. I am the head of Facebook AI research. I can tell you nobody needs explanations. I'm telling you, if you say you, the defendant, are guilty, I'm sure you would like to know what the explanation is. If on the other hand, I say, here are 12 million stupid predictions about what pages you might like next to click on, you may not care. You're probably going to ignore all of my suggestions anyway. So the point is, for some things we do expect explanations. For example, just as you said, you may not necessarily know how something is cooked. You're just happy that it's tasty well. But on the other hand, after eating it, you start dying, then you might want to know exactly how much arsenic was put in the beef. For example. So this business of when you need explanations, it's not always. And in fact, one of the other very interesting things is, you don't ask explanations from agents that you trust. And you ask explanations from the agents that you don't trust. Now that brings up this whole issue of trust and how do we get trust. But the bigger point is, you can't just say explanations are not needed. Maybe in some very specific scenarios, they may be not needed. And that yesterday, last class, we talked about GDPR, Generalized Data Protection things. So in fact, European Union is saying that whenever people feel like they can require Facebook to provide an explanation. You showed me this stupid page and I looked at it and I had like a righteous indignation at the page. And I am entitled to the compensation unless you explain to me why you thought I would like it. Okay. So again, these are good questions. I'm not saying it's clear cut. If it's clear cut, I won't show this. So in some sense, one of the things that I like actually is this particular quote by this guy called Fred Friendly, who is this old man who used to run Columbia School of Journalism seminars, way before your time. And he would pick these really controversial topics like abortion, like gun rights and something, okay? And they have very interesting set of people from both sides argue it out without hitting each other, okay? And then at the end of it, most thinking people would be more torn than they started with. That's why these are interesting issues, okay? And then he would end with this very beautiful saying, at the end of the whole topic, that not to make up your mind, but to open it. To make the agony of decision making so intense that you can escape only by thinking. Okay? That's what I'm doing here, essentially, for a smaller thing. Fred Friendly. Okay. But anyway, so the point is, I'm bringing this here because there is no simple answer. You have to be aware of the both sides, so that you won't come across as some of these people who just basically read something in New York Post and want to opine about AI. There was a question somewhere on the back. Is there that question still? Okay, fine.
So,
yeah.
On a different note, so is there any example where agent has full control over this environment? Maybe in a way it created the environment itself to learn few things or stuff. So in that scenario, we can use the info-based.
It depends. So there can be many special cases. This is the whole reason why I gave examples where this makes sense and examples where this makes sense. And you can write more examples here and more examples there and more examples in the middle too. The bigger thing is for you to understand it's a spectrum, and that in the end, actually the agent needs both the ability to do higher level reasoning as well as ability to learn representations. And if you don't, then eventually I can coerce in your argument. Yes?
When we say that a learning focused agent doesn't
Approximately, that's pretty much what it does. That's what it does. So in fact, one of the most interesting things that's happening currently so again, these are, I put them as two extremes, but there are variations of things as, but for example, some people might seek the learning focused agent to look for, so for example, if you're doing vision, and if you tell your vision agent that there are things called edges in the word, and corners in the word, there's things called textures in the word, you're providing some knowledge. This is how computer vision community thought vision can be solved. Okay, there would be all these named filters called Gabor filter and maybe Rao filter or some other filter, which will look at the filter, the image and remove, bring out these features like edges, for example. Now it turned out that the things that are working right now, for on your cell phones and on the Facebook, essentially, using ConvNets, convolutional networks, the filters are unnamed filters. The machine just figures out what to look for. Sometimes it looks for edges, sometimes it looks for things that we have no clue what it's looking for. Which is exactly the reason of that Rise of AI examples where it looks at a perfectly nice South Indian temple and says it looks like an ostrich. Okay, and you have no idea where it's seeing an ostrich in that temple. You see what I'm saying? Because you don't have common representations. Yes.
So is there anything outside of this for inference and learning? Is there anything outside of this?
What else is there?
I know.
I mean, more or less, I think this is a pretty big picture already.
Yeah.
So it's a pretty big picture. And if you understand this, you may not get a high grade in the midterm one, but you would be a much better, you will have a much more nuanced understanding of where AI is going. Those are very different, sometimes very different.
So basically learning focused models are the deep learning models, basically what I understand. But
Not just deep learning, anything, but deep learning is the learning that seems to be
But
working.
we
Right?
also specify models on that, right? We specify how many nodes that we want.
Yeah, but that's a very different kind of model, right? For example, it's essentially, yes, in some sense there is strange stuff about the architecture that's being provided, but it's not of the kind. So for example, if you're doing a vision system, the fact that you're using a convolutional net architecture, which we will mention, but I assume many of you have heard of the name already, essentially already brings in some pseudo neuroscience into consideration, because neuroscience experiments have shown that visual processing in humans tends to have something related to convolutional architectures. Okay, so but you're starting from there, but you're not telling it anything about there being edges, there being cats, there being dogs, nothing. The rest is all being figured out. Okay, now as if any other questions? Yes. That's basically the whole point. They are supposed to move together to the happy middle right here, where everything essentially they can. So if somebody wants to tell you how the world works, you say, no, sorry, let me learn it myself, you're being stupid. Okay, so if you join a company and the company says, here is the list of rules that we follow, then you say, no, don't show me the rules. That's cheating. I'll try to figure it out myself. By once in a while coming without clothes on, once in a while kind of yelling at people, and then figuring it out slowly myself. That's extremely ignorant thing to do. But at the same time, if there are unsaid rules that nobody is written down and you don't learn it, if you don't have the ability to learn it, that's also very unfortunate. You need both. You need to be able to take representations that if people are giving it, and you need to be able to explain. That's my whole point. Okay? Again, this is way big. After this, we go from sublime to ridiculous or ridiculous to sublime when we start talking about depth first search and breadth first search. Okay, the granularities of the conceptualizations are at a very, very different level. But you have to think about this, otherwise you just basically be pushed into one particular direction. Anyway, so even though much more of the learning focused reflex agents are coming on right now, you do have to give credit to this guy, Rodney Brooks, who essentially many years back, who actually no longer likes deep learning himself, but who many years back essentially argued about this idea of subsumption architecture. Let's make an ant, then make it a little more intelligent, then we make it a little more intelligent, as against let's start going with the human. Okay, so, and not surprisingly, Roomba was from his company. Okay, and is Roomba intelligent? Is it thinking about what should I do next? No, it just keeps moving until it hits a wall and then turns and moves some other direction. That's it. So it's like an ant. And then you can start having next version of Roomba. But for vacuuming, that's pretty good. But may not be good for some other areas, like say law or something where you can't say, give me 3 or 4 lifetimes and I'll figure out how the company works. Okay? But it's worthwhile. This has been called subsumption architecture, where you start off basically let the agent show capabilities that are increasingly more sophisticated, behaviors that are increasingly more sophisticated. Okay, so this is basically the point of interpretable issue. I think I already mentioned this in my discussion, that if the agents learn their own representations and models, will those representations be interpretable by the humans? This is a big issue for those with the adversarial ostrich examples that I have shown you in that thing. Not as much of an issue when we seed the program after agents with our own models outside. Of course, you can seed them. In fact, your parents think that they seeded you with their family values, and then when you become 40 or something, they are just flabbergasted that none of those values remain for you. And that means you have just completely removed those representations, learned your own new representations. That can happen, okay? But in general, at least for a while, they had some interpretability. You were interpretable to your parents. But what about, one very interesting question, actually, is this issue, that's with respect to this other gentleman's question. What if you just leave the agents and they learn everything and maybe we'll understand them anyway? How do you know? How many of you heard of the Nicaraguan deaf children? It's one of these things where it's beautiful, lots and lots of things are connected in general. So this is like a nice digression to have in mind. So this is actually a Wikipedia entry about the Nicaraguan Sign Language. So back in the 70s, there was no deaf community at all in Nicaragua. Basically, if you're deaf, you're just left alone. And like the worst thing that can happen to humans, the forbidden experiment is to take a human baby and leave them in the forest. And let, while Disney thinks that, of course, then the wolves and the bears can take care of the baby, in general, the babies will never learn language. And this is actually very well known. For example, in fact, the forbidden experiment has been done without, obviously, government support by people like some parents. In fact, there were cases where parents would put their kid, they are like basically their parents themselves might be kind of mentally deranged, and so they put their kid in a room and they just throw food for them. And there was one particularly famous case where this girl, I think in California area, was rescued when she was around 13 years old. And until then, she has never seen human touch, and human interaction. Okay, and so she was being fed, people were throwing food to her, but she did not have any human interaction. And it turns out that it's extremely important to learn language. And so, in fact, there's this, completely heartbreaking NOVA program, and people trying to teach her language after she was rescued. And she only reaches a certain plateau, never gets beyond that. And in fact, it's very well known that humans cannot, our ability to understand, learn new languages just keeps going down. It's very interesting as to why that happens. On one hand, we have a big brain and we should be able to learn new things all the time. But language is something we can't learn as we grow older. Another famous case, how many of you know Henry Kissinger? The name. So Henry Kissinger and his brother, their family, immigrated to US when Henry was, I think, 15 years old, and his brother was about 10 years old. And if any of you have heard of Henry Kissinger on TV, you now know that he still has nice, thick Eastern European accent. That just doesn't go away. See, I obviously have gotten my Midwest accent myself, but most people cannot change their accents, it turns out, after 12. Okay, so this guy's brother winds up having basically the normal Midwestern accent. But Kissinger, for all the amount of talking he does on the TV, still has essentially an Eastern European accent. So accent is something that you can't easily change, for example, after 12. Okay, so all of those are interesting, and that brings you to the Nicaraguan sign language. So the deaf children of Nicaragua were left alone, and they were not actually being, there were no other people around them. And so there was actually no language that they were learning. In fact, one of the worst things that can happen to a baby is to have undiagnosed hearing difficulties, because then their language acquisition slows down extremely. And if you do diagnose them, then you start teaching them sign language, and they become just as good as anybody else. They just use a different language, the sign language. Okay, so these Nicaraguan children, essentially, one of the most interesting things is, you can read this as I was saying, they actually invented their own language. They invented their own language, and they were inventing it on the playground of this orphanage. And people in the beginning thought this is all made up, some gobbledygook kids are doing, etc., etc. And they got this lady, Judy Kegel from MIT. She was a linguist, I think, and then she ended up studying it and found this was basically a language with almost the same complexity and sophistication as any human language. And in fact, you can understand this language. It has the same sort of a structure. You see what I'm saying? As human languages, in the sense, we talk about the differences between languages. English is so different from Telugu, is so different from Spanish, etc. But for a Martian, all human languages are all in this little box here. And they are very close to each other. They have very similar structure. And the Nicaraguan deaf children essentially invented a language that falls in the same equivalence class. That should blow your mind. Right? Because these guys just learned everything themselves. And yet they are actually interpretable, at least to an MIT linguist. Do you see what I'm saying? Now, that's actually a very interesting question. I don't have a clear answer as to how that can happen, but the interesting thing is, evolution has basically given us a particular kind of a brain for all of us. And that's why all the human languages are very similar. So in fact, this nonsense that if you leave the kids in the forest, they will start learning how to speak like a bear, how to speak like a dog. Dogs and bears have no language. I mean, it's not that we haven't yet figured out and that they actually are writing books behind our backs. They have no language. And their language is not at all anywhere near the level of sophistication our language is, the human language is. Human language is one small equivalence class, and that pretty much is what you learn. And in fact, if you're born in Mesa General Hospital and we kidnap you and take you to Pettapuram where I was born, you'll speak flawless Telugu as you grow up. But if on the other hand, we kidnap you and take you to Superstition Mountains and leave you alone, you will speak nothing. Because there is no language that you can pick up from. Okay, and so the interesting thing there is the architecture of the brain might itself essentially be biasing people towards learning certain things that are at least interpretable to each other. Okay, we don't quite know whether that happens when we start making agent architectures. Yes.
Should we just support the fact that you won't be able to interpret the machine is so confused?
I don't know, that's what I'm saying. I'm leaving it out there. I don't have answers. I basically am trying to make you realize that, in this case, actually, I think it's partly because we actually share the same hardware. The neural hardware is the same. But the machines, we don't quite know. So we can figure out how to give a biological brain to the machines. And when you get up to that point, one of the more interesting things that somebody said is that the cheapest way to mass produce intelligent agents is something that you learn in junior high already. Okay? And so that's still possible. It's only a question of when you start trying to write programs to make intelligent agents. Okay. So our plan of action for the next few weeks, we will start with the inference focus and then interleave it with learning. Okay, that's what I'm going to do. Given this part that I showed you, we will start with inference focus because after all, we are starting with search essentially. And then we'll interleave with learning and so on. But we are better off than people who just think only this is the world or only this is the world. You should keep this in mind. And every once in a while, should worry that, oh my God, Rob has been spending too much time only on one side and not others. Okay. And then, so in terms of looking at the inference focus, we'll start with atomic representations. which is essentially the states are represented as black boxes, and actions are represented as states. They take you from one state to another state or another set of states. But those also are black boxes. So that happens. And then we'll look at the deterministic case where an agent does an action in a state, it will at most go to one other unique state. Okay? If the action is applicable, it will go to a unique state. If not, it will just stay in the current state. That's deterministic scenario. A non-deterministic or stochastic scenario is when an agent does an action S1, it can go to either S2 or S3 or S4. If it can just go to S2 or S3 or S4, that's non-deterministic. If I say it can go to S2 with 0.6 probability, S3 with 0.3 probability, and S4 with 0.1 probability, then it becomes stochastic. Do you understand what I'm saying? Non-deterministic means I know multiple things can happen, but I don't know what their relative probabilities are. Stochastic means I have an understanding of the probabilistic knowledge. So non-deterministic is the least amount of knowledge. Stochastic is more knowledge. And deterministic is actually stochastic, where the distribution is basically peaked at one specific state, as all probability, all other states have zero probability. So that's why you can think of stochastic as essentially like a nice middle point. Okay, and so we look at first deterministic case where the glory of that part would be a star search. Then we look at stochastic case, and then when we look at the stochastic case, there we switch case and wonder, now that we figured out how to do optimal action in a stochastic model, MDP model, what if the model is not given to us? What is the model? The model basically for these kinds of scenarios is supposed to give you the knowledge of if you do this action in this state, what states will you go to, what probability. If somebody didn't give you that, what would you do? And that's where reinforcement learning comes, and I'll actually do that within like the next 3 or 4 weeks. So that's how learning part comes in, and then we will go again back to representation, again back to learning expert. So that's how we do that. Is this sufficiently confusing? Then I have achieved my goal. Okay. And then of course eventually we will go from atomic agent states to feature-based or structured state representations. We'll do that. Okay, any questions? Okay.
Will our projects be inference focused?
In the beginning, yes. Right after this class. Okay. This guy is leaving when I'm able to do attendance? Okay. Oh, okay. Okay, so we're going to do this attendance thing, guys. The question is, okay, that's the question. Say yes versus no. That's your attendance.
Be honest.
Not directly, not until people are writing paragraphs. It depends. Okay, 114.
Can you do some,
First,
can you do some, the applicant board mentioned that,
well, 114 people already did, so I'm not going to restart. So, a couple of people didn't have, we had trouble just send me short. Okay.
When you logged in, did you use your ASUID? Just the
Okay.
username, the email part?
May I stop? Is there somebody still? If you are texting it to your friends about this secret question, which I'm sure they can actually read from their app, if it's open to there. Okay. It's okay. Yes. Okay, if you have trouble, just send me an email.
I had it, just give me like a second. Okay, good.
I did not think that I made the agony of decision making so intense. Okay, so you have to remember. Okay.
The video be posted right after
Okay. So I basically going to do two activities before we are done. One is explain, because I kept talking about the structure of the state, I want to mention what I mean by the internal structure of the state as an example so that you have a sense. We currently do black box states and then we go beyond that to structured states later on. So an atomic state is one where states are indivisible with no internal structure. So you say S1, S2, S3, and then the actions just take you from these black box states to other black box states. A propositional states are states where they are made up of state variables. So a state is made up of, let's say, k state variables. They can be discrete, they can be Boolean, they can be continuous. But that basically says the way I describe the state is to tell you what the values of the state variables are for that state. A relational state is essentially one relational model is one where you assume that the world is made up of objects and relations between them. Okay, and so it actually makes more assumptions about the structure of the world. Okay, this one just basically makes no assumptions. This one makes a little bit because it says states can be described in terms of state variables. This one says really the world can be described in terms of objects and relations between them. And then the first order representations says basically that not only does the world have objects and relations, but they will be functions over those objects. Okay, now if this is obvious to you, clearly you're on the wrong class. You've done enough logic. Okay, for most of you it's probably not obvious, so I'll show you this slide to give you an example of these kinds of representations. This by now should be familiar if you actually looked at the textbook at all. This is the great vacuum cleaner agent, right? So there are the following states, 1 to 8 in this, right? So the simplest representation is the atomic representation, where you just assume this is state 1, state 2, state 3, 4, 5, etc. 8. Okay, and then actions will take you from states to states. So for example, if you are in state 1 and then if you are in state 1 and you do go right action, then you would be in state 2. Right? And if you are in state 1 and then you do suck action, then you will be in state 5. This stuff is too surprising to you, you never touched a vacuum cleaner and your moms and dads are extremely unhappy. Okay, but this is basically the atomic representation. Right? Okay. Now the interesting thing is look at, okay, so that's that. And here is the propositional or factored representation. The word factored is used, that means the state is factored into individual state variables, and the state representation is a Cartesian product of the values of the state variables. The factor normally means product, right? If you think of factors, that means there should be a product. And Cartesian product is what we have in mind here. Okay, so the states here can be thought of as made up of 3 state variables. One is called dirt in the left room, which can be either true or false. It's a Boolean variable. dirt in the right room, which can be true or false, that's a Boolean variable. The Roomba in the room, left or right, which are the two possible. Notice that having said this, you could easily have made a slightly different representation where dirt in the left room, dirt in the right room. Roomba is in the left room, true, false. Roomba is in the right room, true, false. That's fine. And in fact, you can argue that one representation is more compact than the other representation. Do you understand what I just said? So instead of this, you could have said Roomba, is in the room, left room, and Roomba is in the right room. In that representation, you would think that it is actually possible to have states where there is dirt in both left room and right room, and Roomba is in both left room and right room. Because it's in the Cartesian product. But you know that Roombas basically can't be in two places at the same time, unless you have too many Roombas in your life. Right? So what that means is the Cartesian product now has states that actually are dead states. They don't actually exist in the real world. Whereas this one ensures that the infeasible state is never even considered. Okay? And so in this case, basically doing one variable actually winds up being a more compact representation. It actually winds up being an important distinction. Now comparing these two, one of the interesting things is if you have a second Roomba, if you just bought a second Roomba, because we're talking about getting more Roombas, what will happen to this representation? It just doubles. Now because you have to take care of another Roomba, okay? So in fact, if these are Boolean variables, okay, and if you have n Boolean variables, there are 2 power n states. Right? If you have Boolean variables, then each variable has a domain true, false, true, false, true, false, or yes, no, okay? And if you take the Cartesian product of n true, false sets, you get a big set whose cardinality is 2 power n. In general, for the rest of the classes, if I ask what is the cardinality or something, say 2 power something, because it will likely be the items. Okay? And in general, 2 power n is a really bad thing. It's exponential in n. Okay? So one of the interesting things is, so there are multiple things you can set here. First of all, if you have an extra Roomba, you just basically going to double the representation. Here on the other hand, representation just have one more state variable. Roomba 1 is in with the first variable, Roomba 2 is in is the second variable. If you are talking about software modularity sort of a thing where you are writing your intelligent agent and you want to make its representation be compact so that you don't have to worry about how many places you have to change in the program, clearly this is much better than this. Agreed? It's the same way of thinking that this is assembly and this is C language already. Then you need C++, right? You need objects. That's basically the relational representation, okay? Where you assume that the